Hello everybody, in this video we are going to solve another problem live from LeetCode Stop Interview 150 problem list. So far we have solved all the problems up to 2sum2 input arrays sorted. If you haven't checked out my videos on those problems, please go to my channel and check them out. Today we will pick the next one, which is container with most water. Actually opened it in a new window, so let me drag it and that tab into this one. Okay, there you go. Yeah, this is a problem of medium difficulty. Let's read the problem and make sure we understand it. You're given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height of I. Okay. Find two lines that together with the x-axis form a container such that the container contains the most water. Interesting. Okay. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay, well, I wouldn't have thought of slanting the container anyway, but they have given that, excuse me, as an explicit requirement. To be honest, I did not fully understand the problem, at least not a full intuitive sense. So let me reread. Actually, let's go through an example. Sometimes that is helpful. And then if we still don't understand it, then I'll go back and reread the problem. So let's take this example. So they're given a height array where each of that indicates height of some bar. So that much I understood. So for example, this is height 1 means there's a bar of height 1. 8 means there's a bar of height 8 and so on. And then we form some containers. So I think, okay, so I think in this case they are saying the above article is represented by array. Yes, we understood that. In this case, the max area of water is the container. Okay, I see. Okay, so I think each of these lines can be the left or the right wall of some container. The bottom of the container is always the x-axis. They said that here, I think. Yeah, along with the x-axis, together with the x-axis. Yeah. Okay, I think that was a very mathematical way of describing, but now I understand from the example what they are trying to ask us to do is that each of these can be either the left side or the right side of a container. It's a two-dimensional container, of course, for this problem. And then the bottom of the container is always the x-axis, and we have to figure out which container actually holds the most water. And we are not returning the indices of the right and the left side. We are just returning the maximum amount of water. So in this case, they are saying the maximum amount is 49, which is which is basically here like formed by the left wall being the index 1 bar and the right wall being the index 8 bar, right? So 8 minus 1, so the width is 7 and the height is also 7 because that's the lower of the two heights. Excuse me, scratchy throat today, excuse me about that. Okay, so I think I understand the problem now. Yeah, I mean, like in such problems, there are two thoughts that I immediately thought about. One is that we did a problem which, in a way, sounded similar, or this one sounds similar to that one. We have done this on this channel called, I think it was trapping some rainwater or something. But I think this is very different in a fundamental way. While here we just have to find one container, there we have to find like the amount of water trapped. Given a bunch of bars. I'm not going to go over that problem again. Please go to the channel and look for trapping rainwater problem and look at the approaches we took there. But that was first thing I kind of that rang a bell. And the second thing is for any such problem, like one easy brute force approach is to just look at all the various containers and see which one is going to hold the most water. And that in this case can be done in O of n square because we can say, okay, hey, what are the various left walls that are possible? And for each of those, what are the various right walls that are possible? And then figure out how much water that can hold, right? So even though we have implemented approaches like that before on this channel, It is actually pretty quick to implement, and sometimes it can give us, a good hint about the better approach, right? So let's try that. Max area, let's call it all combinations or all comps, and height. Okay, so this is pretty straightforward. Since we have done this before, I'm going to go a little fast. So we basically say, hey, okay, we have to keep track of max, right? Max water we can hold. So let's have some variable to keep track of that. But otherwise, we have left that can be anywhere from index 0 to index less than height dot length. And then we have, for each of those left, we have various possibilities for right. And right can start, or has to start from left plus 1, right? And right still is less than height dot length plus right, correct? So yeah, and there you go. And for each of that we say, okay, hey, how much water can that hold? Okay, let me make some more space for this code panel. Okay, so we say, okay, hey, what is the width of this? Well, the width is right minus left, right? Width of the container. And what is the height of the container? The height of the container is the lower of the two heights, right? So it is math.min height of left, comma, height of right. Okay, and then how much water can that hold? So we say, okay, hey, into water equals, actually height is already defined. I'm going to just call them h and w, right? So w times h, and then we say if that is better than max, which means we found a container which can hold more water than what is the best so far, then we update the maximum, right? And that's pretty much it. Like this should pretty much work, right? And again, like I said, it's a brute force approach. It just takes all the various possible containers and figures out which one is the best. Let's just call it from here, max area all comps height. And this should work. I mean, may have some compiler errors or some bugs, but the approach should work. Okay, there you go. So the approach worked. And I mean, I can try to submit this. I do feel that if I try to submit this, it's going to either be very, very slow compared to all other submissions, or it's going to fail one test case or some test cases because of time limit exceeded or something like that. But let's see what happens. Okay, yeah. So as I suspected, it failed a few test cases. Looks like, yeah, a handful of test cases because of time limit exceeded. And as you can see, like, yeah, these test cases have a really long array that they are passing as the height. Okay, so that makes sense. Now, how do we make this better, right? So, well, I mean, before we think of the approaches or we take like, you know, this algorithm and see what we can do better, in such cases, I generally like to kind of, create my own visualization so I can play around with some inputs. So let's do that. I think we did that for trapping rainwater. Yeah, in fact, yeah, I think we did that for trapping rainwater. So we are going to do something similar here. It should take a minute. So, and it will be very useful. Could be very useful. Not sure if it will be, but I think it will be useful. Okay. So let me drag this here. Okay. Let's see what are the values here in this example at least. 18625, 18625, 4837, 483 and 7. Okay, and what I'm going to do is quickly create like a column chart or bar chart or something like that. Chart. Okay, good. Actually, it chose column chart as the default, and that's actually what we need. So I'm just going to do this. Okay, so the reason I did this is I think we can actually play around with some values and change them and see like what happens. So, okay, so let's take the the brute force approach, right? Now, brute force approach is, let's say I comma j is a container defined by I in index being the left wall and j index being the right wall, right? So what we are doing is we are basically going through all the values of I and all the values of j and kind of taking all the containers. And the first observation I have is because of the nature of the problem, right? Let's say we have some arbitrary container. Let's say 2 comma 2 comma 5. Actually, let's say 2 comma 7, right? So 2 is the left wall and 7 is the right wall. Well, how much water can that hold? Well, the width is 7 minus 2. So width is 5. The height is the minimum of the two heights, which is 3. So 5 times 3, that's 15 square units of water that can hold. Okay. So one thing is that what we are doing in our brute force algorithm is that when we did 2, we would have taken 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6, 2 comma 7, and 2 comma 8, and we would have figured out the best among them, right? After that, we would do the same with 3. We would do 3 comma 7, but note that 3 is smaller than 2, and 3 makes the container less wide as well, right? And 3 smaller as in 3 shorter than 2. So it neither increases width nor it increases height compared to 2. So there is no possible way a container with left wall 3 is going to give us more water than container with left wall 2. Right. So given that observation, we can actually already eliminate a bunch of, combinations, or at least some combinations from our algorithm. And that by itself is not going to change the time complexity of O of n squared. But if we were to implement something like this, I think what we would do is basically we are trying to eradicate the inner loop for some values of left, right? So we say something like this, right? Prev left height or prev left is that. And what I'm going to do here is if height of left is less than prev left, then we just continue. We don't execute this loop, right? And the reason is I implemented literally what I just said here, right? The previous, when we come to 3, our previous height will be the height of 2. And if this height is smaller than this height, then don't even bother looping for that, right? And like I said, it's not going to fundamentally change the time complexity. It's still O of n squared, but it does practically will run faster for some inputs. Okay, so that's one thing we can do. Now, what else can we do? I mean, like, we can apply the same idea on the other side, right? So for example, when we do 2 comma 7, and after that, if we are looking at 2 comma 6 or 2 comma 8, we could still do the same thing that, okay, hey, is that bigger? Like, and in this case, 8 and 6 are both bigger, so it is worth considering 2 comma 6 and 2 comma 8 compared to 2 comma 7. For example, 2 comma 6 will hold how much water? 6 minus 2 is width 4 and the minimum height is 6. So yeah, that is already holding more water. So it's worth considering. But if we were doing 2 comma 6, for example, then 2 comma 5 or 2 comma 7 are not going to give us better answers, right? Especially 2 comma 5 actually, because that makes the container less wide, right? So we can apply the same idea for the left wall. We can apply the same idea for the right wall. So I think that is what we need to figure out. How do we do such that we don't, do quadratic time? And the biggest hint actually comes from the fact that they have categorized this problem under 2 pointers. And again, I have mentioned in one of the previous problems as well that I don't like the fact that LeetCode categorizes the problems under types of solutions or approaches which work to solve the problem. I wish they categorize the problems by the type of problems. But anyway, it's fine. I think they do a good job of categorizing the problems in general. But here the hint is from that thing, right, from the 2 pointers section, and that is, okay, what if we take the widest possible container? Well, left is initially 0, and in this example, right is initially 8. 0 comma 8 is the container, and we keep on adjusting left or right based on the heights of 0 and 8, based on the current heights, right? So of course, first we compute how much water that can hold. So how much can 0 comma 8 hold? Well, the width is 8 and the height is 1, right? So it can hold 8 units of water. So we say, okay, is that better than our best so far? Our best so far was 0. We haven't done anything. So yeah, that's possibly one answer. but then we move either the left one to one right or the right wall to one left. And which one do we pick? And this is where, combining what we initially said or going back to what we initially said, I think what we want to do is we want to pick the smaller of the two walls and move that one, because that could potentially give us a better answer. For example, 0 is shorter than 8. And that's why we want to move the left one to 1 and see if it is actually has a taller height than 0. And the reason we want to do that is if we move 8 to 7, we may be potentially never be better than 0, 8, right? And actually, indeed, it is the case in 0, 7. So that's why we want to move the tower or move the side whose tower is shorter, right? So in this case, we want to move the left one to 1 on the right. So now we do 1, 8. Well, 1, 8 turns out is the best answer in this case is 49. They already gave that. In this case, I mean, that is where, we get the best answer, but note that we cannot stop there. And the reason is, like, let's say that 49, right? So let's say this was 50, right? Height 50, and this is also height 50. Well, even though 1, 8 gave us 49, we don't know that's the best, and we need to continue the same algorithm and keep going because there could be like really tall towers in the middle, right? So that's why we cannot stop, but the algorithm stops when left and right cross each other, right? So that's kind of the O of n algorithm that I think should work. So let's try to implement that. A private int max area. Let's call it fast. I've used that terminology before for lack of better name. Okay. And then we say int height. Okay. So what are we doing? Well, we still want to keep track of max. And we start with left equal to 0 and right equal to height dot length. Oh, sorry, height dot length minus 1, the last index, not dot length. And then we say while left is less than right, correct? And we do similar thing to what we did before, right? We did here, in fact, I can copy paste these 3 lines, or in fact, these 4 lines, right? So you say, hey, width is right minus left, height is the minimum of the 2 heights. The water it can hold is width times height, and if that is better than the maximum, we are going to update maximum. So that all still stays the same. I'm going to just do this. Sorry about that. Just a bit pedantic about these things. Okay. And then what we do? We either update left or right, and that depends on the height, right? So if the height of left is less, and equal to can go either ways, right? If the heights are equal, it doesn't matter which one we actually change. So I'm just going to arbitrarily pick equal to on the left side. Then we do plus plus left, right? And else we do minus minus right. And that's pretty much it, right? So we just implemented the same algorithm we just talked about. Now let's just convert this to calling the faster version, and let's run and make sure it actually works. Okay, so that worked. And just like I always do, if we have considered other test cases to complete our algorithm, I always like adding them. So I'm going to make this 50, make this 50, and make sure it actually returns 50. Let's see. Yeah, it returned 50. That makes sense. Okay, cool. Now let's just submit this and see what happens. Unless there are some bugs, it should definitely not do the time limit exceeded thing. Okay, it did get accepted, looks like. Yeah, it did get accepted, and we beat about 88% people in time, which is reasonable. I think a lot of people would have, submitted this kind of solution. Memory, it beats 97%, but honestly, I wouldn't really pay attention to that. When there is overflow memory consumption and a lot of submissions like that, this number is actually quite noisy. If I submit again at some point, I'm pretty sure it might say like 15%, beats only 15%. Anyway, hopefully that made a lot of sense. Like I said, we have solved problems like this before, where, we take a brute force approach and that works, but then we find one, 2 tricks or ways or ideas which allow us to not really have to consider all the combinations and get rid of a lot of combinations. and that makes the algorithm O of n. Hopefully that was useful to you guys. If you're liking what I'm doing on this channel, please consider subscribing to the channel and hit that thumbs up button on the video. See you guys next time.